So remaining problems are same kinds of problems. You please practice yourself, work out yourself and verify the answer and try to complete that exercise. Try to complete all the problems. Okay, right. I hope that you can easily understand the matrix and determinants, chapter number 3 and 4. Now we are going to enter that chapter number 5. This chapter 5, 6, 7, 8, 9. Okay, these 5 chapters are called as calculus. Okay, in this 5 chapters, that means in this calculus, the 35 marks will come in your board exam out of 80. Okay, so you're going to write that. I'm telling about the previous year pattern. I don't know about this year. It may be changed, but definitely the weightage, look at the weightage of this calculus. You have to realize that you have to see the weightage of this calculus. Okay, so 40 marks means it is 50%, 35 marks it is nearly 45 to 50%. Okay, so nearly 50% weightage given for this calculus. Calculus means chapter number 5, 6, 7, 8, 9. But 5, 6 is chapter number 5 and 6 is differential calculus, and 6 and 7 that is integral calculus, and your 9th chapter is your differential equation. Differential calculus, integral calculus, and differential equation. That means differentiation, applications of differentiation, integration, applications of integration, and differential equation. All these 5 chapters together called as calculus, and we in your board exam out of 80 marks, 35 marks will come only from these chapters. Okay, so the most weightage part of in your plus 2 max book calculus, right? What about the others are not important as well. Other chapters also important, but compared to that chapters, these chapters are very important. So the chapter name is continuity and differentiability. Continuity and differentiability. First, we are going to discuss about continuity. First, we are going to discuss about continuity. Are you able to hear my voice and the video is visible? Any problem in that? Video is visible, PCV is visible. I think no problem. Okay. So now look at that. What is continuity? First of all, take that example. Suppose your f of x is equal to 1, 2. If your x less than or equal to 0, if your x greater than 0, what is the graph of this function? What is the graph of this function? The graph of this function is when x is less than or equal to 0, whatever it is, minus 1 or minus 2 or minus 3 or minus 5 or minus 100. When x is less than or equal to 0, your y value is plus 1. Okay, when x is equal to 0, again your y is plus 1. Y means f of x. When x is equal to 0, your y is 0. That is f of 0 is 0. Sorry, 1. That is your y is equal to 1. Then x greater than 0, look at that. When x greater than 0, positive value, what is your f of x? Not equal to 0. When x equal to 0 means your x is f of x is 1, but x is more than 0. Greater than 0 means not equal to this point. This point not included, but this is okay. So therefore, this is your x, this is your y. That means f of x. Okay, look at that. So therefore, this is your f of x, this is your f of x. Now see the graph. This graph is continuous or not? See the graph. That graph is continuous or not? See the graph. Based on the graph, you conclude that the entire graph is continuous or entire graph is not continuous. Not continuous means at which point it is not continuous. Any particular point is there. At which point the function is not continuous. Look at that at x is equal to 0. At x is equal to 0, okay, the function is not continuous. Look at that. This gap. This is the gap. Okay. So this function is not continuous at x is equal to 0. Because at x is equal to 0, here 1 is there. But more than 0, the function goes to 2. Okay, so look at the gap. So the function is not continuous. Right. Now see the second example. After the example, we will discuss. We go for the definition and everything. The second one is your f of x is equal to 1, 2, this is x not equal to 0, this is x is equal to 0. What is the function? How to draw the function? Some students are asking about the draw the function. How to draw the function? Graph of the function. How to draw the graph of the function? So this is take it as 1, 2, 3 like that. When x is equal to 1, what is your y2? When x is equal to 2, what is your y2? When x is equal to 3, what is your y3? When x is equal to 4, what is your y4? 2. So now trace the points. That means connect the points, you will get the curve. Similarly, when x is equal to minus 1, x is equal to minus 2, this function y only. Y is equal to 1 only. F of x is 1 only. When x is minus 1, your y is 1. When x is minus 2, your y is 1. So therefore, connect all these points. Okay. So then you will get the graph of this function when x is less than or equal to 0. If you connect these points, you will get the graph of this function when x is greater than 0. Similarly, here come to that. When x is equal to 0, what is that? X is equal to 0 means the function value is 2. This is your 2. When x not equal to 0, not equal to 0 means either positive or negative, both. Your y value, that means your f of x is nothing but y value is 1 only. Suppose this is take it as 1. When x is equal to 0, the function value is not equal to 1. Y value is not equal to 1. But other values, this is a straight line only. Okay, for any, if you take any value minus 1, the function value is 1. Minus 2, the function value is 1. Plus 1, the function value is 1. Y value is 1. Plus 2, the function value is 1. Okay, but x is equal to 0, the function value is not equal to 1, it is 2. That is here. Okay, now see that the function is continuous or not at x is equal to 0. At x is equal to 0, the function is continuous or not. See the gap. Up to 0, the function is coming like that. Up to 0, the function coming like that, the graph of the function coming like that, and 0, it is jumping. Okay, again come to jumping here and continuing the graph of the function. Okay, so therefore, please try to understand that the function is not continuous at x is equal to 0 here. And here also the function is not continuous at x is equal to 0. So therefore, here your f of x is not continuous at x is equal to 0. Here also your f of x is not continuous at x is equal to 0. Okay, sir, you are giving the example for not continuous. What about continuous? What is the definition for condition? What is the definition for continuous? How to prove that it is not continuous? I have to prove that it is continuous. Okay, so now look at the definition. Let definition, let f be a real function and c be any point, c be a point in the domain of f, c be the point in the domain of f, then f is said to be continuous, then f is said, then f is said to be continuous if limit x tends to c f of x equal to f of c. Look at that. Your limit value and value of the function at c, both are same, then the function is continuous. Otherwise, it is not continuous. Okay. See that first example. Here, come to the example. What is the point? This is the point I am taking. This is the point. I am taking 0 is the point. X is equal to 0. I am going to check that the function is continuous or not. How to check that? I am going to find out my limit x tends to 0 f of x. Okay. Actually, what is your f of x? Limit x tends to 0 f of x means you have to apply this f of x or this f of x. Okay. So if you apply this f of x, you will get the f of x is 1. When you apply x tends to 0, I will get the value is 1. Okay. If you apply f of x is equal to 2 and taking the limit x tends to 0, my f of x is equal to 2. Okay. If you take this this is f of x, okay, that is called as left hand limit. If you are considering this is your f of x, then the limit is called as left hand limit. If you are considering this is your f of x, that limit is called as right hand limit. Okay, so for in both f of x, you just apply x is equal to 0. You are getting the value of the limit is 1 and 2. These two are not equal. The value of the function is a value of the limit is also not equal. Okay, and what is the value of the function? F of 0. This is value of the function. When x is equal to 0, what is the value of the function? That is 1. If all these three are equal, then only the function is continuous. Otherwise, not continuous. So therefore, the function is not continuous. This is a mathematical term. This is the graphical term. Okay, but this graphical term is not possible for all the functions, but this mathematical term is possible for all the functions. We can verify that. Look at here, limit x tends to 0, f of x. What is my f of x here? Here also. Right, here also my f of x is, when x is not equal to 0, this is my f of x. Don't take it as when x approaching 0. This means x approaching 0, x not equal to 0. So therefore, where x is not equal to 0 means this is where f of x, and apply x is equal to 1, you will get the value of the limit is 1. But what is the value of the function? My value of the function is 2. F of 0, when x is equal to 0, f of 0 is 2. Value of the function is 2, limit of the function is 1. So therefore, these two are not same. Therefore, the function is not continuous. Okay, so therefore, this condition not satisfied in both the previous examples. Okay, so therefore, the function not continuous at a particular point. Okay, okay, so still if you are not understanding means we'll discuss some more problems you can easily understand. Okay, we are going to discussing many problems in this section. So don't worry about that. So the first one is here you can take f is said to be continuous means f is said to be continuous at x is equal to c. You please add one more point. f is continuous, f is said to be continuous at x is equal to c. At x is equal to c, if limit extends to c, f of x is equal to f of c. If f is not continuous at x is equal to c, then f is discontinuous at c. Discontinuous at x is equal to c. Look at that, this is continuous. You please note that this is function, short form, this is point, short form, this is continuous. So I'm writing in short form, you please write properly, don't get any confusions. Not continuous, this is discontinuous at x is equal to c. Not continuous means that is discontinuous at x is equal to c. Okay, and this point c is called as, and c is called a point of discontinuity. C is called as point of discontinuity. Okay, so now we will discuss some examples. You can get an idea. Check the continuity of the function f. Check the continuity for the following function. Number one, f of x is equal to 2x plus 3 at x is equal to 1. What is the continuity condition? Limit x tends to c, f of x equal to f of c. Okay, here your x is equal to 1. This is your given c. This is your c. X is equal to 1, your c is equal to 1. Okay, so therefore, first of all, find that value of this function f of 1. What is the value of the function? Value of the function means just replace x is 1. Therefore, this is 2 into 1 plus 3. This is 2 into 1 plus 3, that is 5. So that is the value of the function. Okay, right. Now come to that limit. Limit extends to c. F of x is equal to, limit extends to 1. Your c is 1. F of x, what is my f of x? 2x plus 3. How to find out the limit? So some students are still having problem in finding the limits. How to find out the limits? The limit is x tends to 1, 2x plus 3. The limit of the function 2x plus 3 at x tends to 1 means you just substitute this x is equal to 1. Okay, substitute this x is equal to 1. What is the answer? This is also 2 into 1. It is 3. 2 plus 3 equal to 5. So now look at that. This is 1, value of the function. This is 2, limit of the function at x tends to 1. Both are same. So if both are same, then the function is continuous at x is equal to c, at x is equal to the given point. So please note that the function is continuous at the point. Okay. So from 1 and 2, What is that? Your limit extends to 1 f of x and f of 1 both are having the same value, which implies my f of x is continuous at x is equal to 1. Okay. Look at the second problem. Your f of x is x square at x is equal to 0. Check whether the function is continuous or not at this point. Okay, your c is equal to 0. Therefore, first of all, find f of 0. That is 0. Now come to the limit. Limit extends to 0 f of x. What is limit f of x? Your f of x is limit extends to f of x. What is your f of x? Where f of x is x square. Okay, now how to find out the limit? Yeah, please try to understand. Some students still having the problem in finding the limit. Limit is nothing but you just substitute the value here instead of x. Okay, substitute here. What is the answer? So I will get 0 square. So therefore 0 square is again it is 0 only. So now look at that. This value of the function and limit of the function both are same. The value of the function, limit of the function both are same at the point. F of x is equal to f of 0. Okay, which implies your f of x is continuous at x is equal to 0. So why is there in all the problems you are getting like that only, sir? What is the difference between the continuous and discontinuous, sir? Here also you are applying 0. Here also you are applying 0. Both are same done, sir. Yeah, look at the third problem. Your f of x is equal to x cube plus 3, 1, x not equal to 0. Here x equal to 0. So you have to verify the function is continuous or not at x is equal to 0. What is the value of the function? First, at x is equal to 0 only, we are going to discuss about the function is continuous or not. What is the value of the function? That is 0. When x is equal to 0, the value of the function is 1. Are you okay? Any doubt in this? Value of the function f of 0 when x is equal to 0, because I am taking the point is 0. I am going to find out the f of c. What is my f of c? F of 0. What is f of 0? When x is equal to 0, the value of the function is 1. Right, now come to that the limit x tends to 0 f of x. Now come to your f of x. Limit x tends to 0. What is your f of x actually? Look at that. This is x tends to 0, not equal to 0. X tends to 0 means x approaching 0. X is nearby 0, not equal to 0. Exactly. Okay, so therefore this is x not equal to 0. This represents, you please try to understand, this represents x is nearly 0, not equal to 0. Not equal to this point. So therefore, that is x not equal to 0 means what is your f of x? Your f of x is x cube plus 3. Your f of x is x cube plus 3. Now apply 0. Finding the limit. How to find out the limit? Just apply 0. Apply this limit value. When you apply this limit value, x is 0 here, what is the answer we are getting? 0 cube plus 3. What is the answer we are getting? 3. Look at that. My limit value is 3. My limit value is 3, but the value of the function is 1. From 1 and 2, your limit value is not equal to the value of the function. Please try to understand. Limit x tends to 0, f of x is not equal to f of 0. These two are not equal. Not equal means what happened? What is the definition? Not equal means if it is equal, it is continuous. It is not equal, it is not continuous. Okay, that is the definition. So therefore, your f of x is not continuous at x is equal to 0. Okay, please note that. Okay, now go to the next problem. Discuss the continuity of a constant function. F of x is equal to some constant. Okay, here the point is not given. Discuss the continuity of the function. That is the question, right? So that is the question means you have to take it as any point at x is equal to c. C be any point. Okay. So c be any point. Right. Now what is the value of the function? Your value of the function is k only, because we are replacing, substituting x by k, x by c, but here there is no x, so therefore the function again it is constant. Right, now come to the limit of the function. Limit extends to c f of x. Actually, what is your f of x? Your f of x is k. Okay, now you are going to just substituting the value of x is c, but here there is no x, so therefore it is again k. So therefore from 1 and 2, look at that, the limit of the function and the value of the function, limit extends to c f of x, and the value of the function f of c, all are same. Okay, so therefore which implies your f of x is continuous at x is equal to c. What is this c? Your c may be any point in the domain of f. Any point. Here particular point. Here look at that. Here the first problem. Here we are defining, we are discussing the continuous at a point x is equal to 1. Here at x is equal to 0. Okay. So in previous problem also, here at x is equal to 1. We are defining the function, continuity of the function at some particular point, but here there is no point. General point is given. General point means any point you can take it as from the domain of f. Okay, so that means for any point the function is continuous. That is the meaning. So therefore at every point or any point the function is continuous means the function called as simply continuous. No need to take it as f is continuous at x is equal to a, x is equal to 2, x is equal to 1, x is equal to 5. Simply write as f is continuous. Okay, so therefore that is the next definition. You please take one more problem. After that, take a definition. Your f of x is equal to an identity function at x is equal to any point. What is my c? C only. Here it is k. Here there is no x, but here it is x is there. In place of x, you have to substitute c. Therefore, f of c is equal to c. Similarly, limit extends to c f of x. Limit extends to c. What is my f of x? My f of x is x. Okay. So limit extends to c. My f of x is x. So now substitute that. C is equal to x as c. So therefore, I am getting c only. So therefore, my value of the function is also c at the point x is equal to c. The limit of the function at x tends to c is also c. So therefore, from 1 and 2, these two are equal. Limit x tends to c, f of x equal to f of c. Both are equal, which implies f of x is continuous at x is equal to c. Okay, so here also this is a look at that. This is a general point. General point means any point, not a particular point. Not x is equal to 0, not x equal to 1, not x equal to 2, not x equal to 5. At any point, the function is continuous. Every point it is continuous. That is the meaning. Okay, so the next definition is the function is continuous at every point of the domain, then the function is said to be simply continuous. That is a definition. You please take the definition. A real function f is said to be continuous if it is continuous at every point in the domain of f. Okay. Not this constant function. Now only I have told this constant function is continuous at every point of the domain. Okay. Similarly, this is called as identity function. Your identity function is continuous. So therefore, your constant function is continuous. Your constant function is continuous. Identity function is continuous. You take it as every constant function is continuous, and identity function is continuous. Okay. Similarly, every polynomial function is also continuous. Every polynomial function is also continuous. Take the third one. Every polynomial function is continuous. Now look at that. Your f of x is equal to k. What is the graph of this function? What is the graph of this function? F of x is equal to k. This is x-axis. This is y-axis. Okay. What is the graph of this function? This graph is equal to k. Y is equal to k. F of x is equal to k. Okay. So if x is a power plus 1, here also plus 1. Okay. If x is 2, it is k. X is equal to 3, it is k. 4, it is k. 5, it is k. 0, it is k. Minus 1, it is k. Minus 2, it is k. How to draw the graphs? Are you just give the x value. When x is equal to 1, what is your yk? When x is equal to 2, what is your yk? When x is equal to 3, what is your yk? You just plot the points and connect the points, trace that, you will get that graph. Okay, curve. So therefore, this is y is equal to k. If k is greater than 0 means your graph of the function is above the x-axis. K is greater than 0. If your k is less than 0 means your graph is straight line. Graph is below the x-axis. If k equal to 0, that is along the x-axis, that is x-axis. Okay, k is equal to 0 means the x-axis is the graph. K greater than 0 means above the x-axis straight line. Horizontal straight line is the graph of this function. Now see this function. This is continuous or not? There is no break. Without lifting pen, we can draw the curve. Without lifting pen, you can draw the curve mean that is also continuous. So therefore, this function is continuous. Okay, at all the points here, you take any point at x is equal to 1, it is continuous. X is equal to 2, it is continuous. X is equal to 3, it is continuous. X is equal to -1, -2, it is continuous. Okay. Now let us take it as the identity function. Your f of x is equal to identity. Your identity is nothing but y is equal to x. What is your y is equal to y? We very well known that y is equal to x. This is y is equal to x. Okay, see that your y is equal to x is also continuous. With the lifting pen, I am writing, I am drawing the graph y is equal to x. This is the identity function, graph of the identity function. See the graph. From the graph, we can easily conclude this is the continuous function. Okay, suppose I am taking the third one, polynomial. Every polynomial function is continuous. If you take f of x is equal to x square, quadratic polynomial. Usually, what is quadratic polynomial? Ax square plus bx plus c. This is a quadratic polynomial. Okay. And here, what is A1? What is B0? What is C0? So therefore, this is a quadratic polynomial. We know that what is the curve for this x square? This is a parabola. Y is equal to x square. Look at that. This is also continuous. Okay. So therefore, these are the examples for the continuous functions. A graph of the continuous functions: constant function, identity function, parabolic function. Okay. Look at the example. Some example. Discuss the continuity of the function. Discuss the continuity of the function. F of x is equal to x cube plus x square minus 1. Discuss the continuity of the function f of x is equal to x cube plus x square minus 1. This is a polynomial function. Okay, so we have already known that polynomial function is always continuous. Continuity all the points. So let us take it as x is equal to c. I'm going to check that. I'm going to verify that. Okay, this function is continuous or not at any point. I'm going to take it as any point c. So what is the value of the function? My value of the function is just substitute c cube plus c square minus 1. What about my limit of the function? Limit extends to c. F of x. Actually, what is your f of x? Your f of x is limit extends to c. Your f of x is x cube plus x square minus 1. Okay. So now substitute x is c. So therefore c cube plus c square minus 1. So from 1 and 2, we are getting same value c cube plus c square minus 1. So therefore from 1 and 2, we will conclude that limit extends to c f of x equal to f of c. If both are equal means your f of x is continuous. At x is equal to c. So at any point the function is continuous means your f of x is simply said that continuous. Your f of x is simply called as it is continuous. Okay. Now come to that. How to prove that every polynomial function is continuous? We have already taken polynomial function is continuous. Okay, the proof is a very simple one. So we'll go to the next problem. Come to that problem, f of x is equal to, discuss the continuity. Of the function f given by f of x is equal to modulus of x at x is equal to 0. Okay, please note that this is a very important problem. Not this problem, the concept of proving continuous is very important, because based on that we are going to discuss about other problems also. Okay. Actually, what is your modulus of x definition? Your f of x is equal to modulus of x. What is your actually modulus of x definition? Your modulus of x definition is minus x when x is less than 0, plus x when x is greater than or equal to 0. Right. So now I am going to prove that the function is, I am going to check that the continuity of the function at x is equal to 0. What is the continuity definition? I am going to check that limit x tends to 0, f of x is equal to f of 0. If this is equal, limit x tends to 0, f of x equal to f of 0, this is equal, these two are equal, then the function is continuous at x is equal to 0. Value of the function and limit of the function, both are 0, both are equal, then the function is continuous at the point x is equal to 0. Right. Value of the function, that is very simple. What is the value of the function? This is, we can calculate easily. What is the value of the function? Here only x is equal to 0 is there. When x is equal to 0, what is your f of x? When x is equal to 0, your f of x is x. Because here only x is equal to 0 is there. This is your f of x. Okay, so therefore, your f of x is also x. Actually, what is x? It is 0. So therefore, your f of 0 is 0. When x is equal to 0, here also you have to put that 0. So therefore, your f of x is equal to 0. Value of the function is 0. Okay, now come to that limit of the function. How to find out the limit of the function? Yes, if you have any doubt means you please send a message. This is a very simple concept and important concept, only one exercise. But your second, from the second exercise, it is different. That means we are going for differentiability. Only first exercise is continuity, second exercise is differentiability. The first exercise only we are going to discuss about that continuity. If some students are getting bored means or not understanding means, you please try to understand. You please read the concept once or twice again. Definitely you can understand. Now look at that. I'm going to prove that f of 0 is equal to limit x tends to 0 f of x. My f of 0 is 0. Okay, because x is equal to 0 means my f of x is x. X is 0. Apply 0. What about your limit x tends to f of 0? So I'm going to find the limit value. Limit x tends to 0 f of x. Okay, actually what is your f of x when x tends to 0? This is meaning not meaning that x equal to 0 or not equal to 0. The x is approaching 0. That is the meaning. Okay, when x tends to 0 f of x, what is your f of x? There are two f of x. Here also f of x, here also f of x. Both are nearby 0. Here 0 and more than 0. Here it is also less than 0 means it is also nearly 0. Okay, so you can, for x tends to 0, you can take it as this is also f of x and this is also f of x. So therefore, I'm going to apply both f of x. I'm going to apply that first f of x minus x. I'm going to take it as minus x. Now apply 0. When x tends to 0, what is the answer? It is 0. Again, I'm applying that x tends to 0 f of x, limit x tends to 0. Okay, what is actually my f of x? Here, second f of x. I'm going to take it as this f of x, that is x. Apply 0. When x tends to 0, that is the limit value. Okay, limit x tends to 0 f of x. What is the answer? Here also it is 0. Okay, right. Why, sir, you are applying 2 f of x? Yes, the function given in two terms, and when x less than 0, one function is given. When x greater than or equal to 0, another function is given. Both are nearby zeros. Okay, both are nearby zeros. So therefore, I'm applying that first f of x and finding the limit value, applying second f of x, applying limit value. Please try to understand, when you apply this f of x, okay, then this limit value, because x is less than 0, your x is, you are going to take it as, that means this f of x is taking the value of x is less than this 0, less than this point. Less than this point means your x is less than, your x value, you are applying that x value less than this point value means this entire limit value is called it as left hand limit. This is left hand limit. This is left hand limit. Okay, right. If you take x is greater than 0, that means more than 0. Okay, your x is approaching from positive values from this 0. Okay, so then this limit is called it as a right hand limit. Okay, this is left hand limit, this is right hand. Why, sir, in previous problem you didn't apply that left hand limit, right hand limit, everything, but here only you are applying. In my previous problem, I have only one f of x, but here I have two f of x. That means they are classifying in my f of x. When x is less than 0, your f of x is minus x. Here x greater than or equal to 0, I am getting plus f of x, plus x. Okay, so therefore the meaning for this left hand limit is when my x approaching 0 from negative numbers to 0. Okay, here when x is approaching 0 from positive numbers to 0, that is the meaning. This is negative number. Okay, this is positive number. My x is approaching 0 from positive numbers to 0. Left hand limit means that is my negative numbers to 0. Are you okay? And the symbol. So no need to write that left hand limit, right hand limit. The symbol. If you are putting minus here, This minus denotes a left hand limit of this f of x at x tends to 0. Right here, if you put plus here, then this is denoted as right hand limit of f of x when x tends to 0. Okay, right. If these two are equal, limit x tends to 0 minus f of x. Okay, limit x tends to 0 plus f of x. Okay, so this is nothing but your limit of the function. Are you okay? If a left hand limit and right hand limit both are same, that is the limit of the function. Here both are same. Okay, so therefore this is where 2, that is value of the function is this only 0. Both are equal, then that is equal to limit of the function. So therefore the limit of the function here it is 0. This is equation number 2. What is the value of the function? My value of the function is also 0. So therefore from 1 and 2, this is my value of the function. And this is the limit of the function, which implies limit x tends to 0 f of x and f of 0 both are same. Okay, which implies my f of x is continuous at x is equal to 0. My f of x is continuous at x is equal to 0 because limit x tends to 0 f of x left hand, that left hand limit, right hand limit, and the limit value and the value of the function at x is equal to 0, everything is 0. So therefore my f of x is continuous at x is equal to 0. Okay, so now look at that. What is the difference between this problem and the next problem? Please note that this problem, look at the next problem. First, what is the difference between the problem? Is the function defined by, if the function defined by f of x is equal to modulus x, a continuous function, a continuous function. What is the meaning for that? What is the previous problem? What is this problem? The previous problem is f of x equal to modulus x is continuous at x is equal to 0 or not. That is a question. But here only continuous is given. Only continuous means the function is continuous or not. Continuous means, just now I have given one definition. Simply continuous means the function is continuous at all the points. Every point. The function is continuous at every point of the domain. Okay, sir, how to check that for every point, all the point, how it is possible to check that, sir? You no need to check for all the points. You check it generally. Check it as, take x is equal to c. Don't take it as x is equal to 0. For particular point means you take it as particular point x is equal to 0 or x is equal to 1 or x is equal to 2 or x is equal to 3. Okay, if the question is they are asking the function is simply continuous, not they are not asking about the point, not discussing about the point, means you have to check that the general point x is equal to c. Okay, how to check that this function is continuous or not? That means at x is equal to 0 the function is continuous. Yeah, it is okay. Look at that. This is at x is equal to 0. See the graph. At x is equal to 0 the function is continuous. What about the other points? Suppose I am taking x is equal to 1. X is equal to 1 also the function is continuous, no problem. X is equal to 2, that is also no problem. The function is continuous. So therefore, at every point, the function f of x modulus of x is continuous. But how to prove that? So instead of 0, here you are taking 0. At x is equal to 0, we are choosing. Okay. But what I am telling means, instead of 0, you can take it as any C point C. Let x is equal to C, or C belongs to R domain. Okay. And let x is equal to C. Any point means general point means you can take it as C. Instead of in place of 0, you just apply C in left hand limit, in right hand limit, everywhere. Okay, try to complete this problem. In place of C, in place of 0, you replace C. Okay, then you can easily complete the problem. The function is continuous. Right? This is a homework. Try now, complete this problem. Your homework is the example problems. Some example problems are given in your NCERT book in this first chapter, first section, that are homework problems for you. Try to complete these homework problems. Okay. Now look at that. If anyone wants the slide means, this is our first slide. This is the second. If you want any snapshot or a doubt means, you please verify that, check that, take that. Okay, thank you all. Thank you so much. You please go through the book and try to complete the example problems. We'll discuss exercise problems in our next class. Thank you all. Thank you so much.